Okay, first, quick reminder, anybody who missed the quiz on Friday, please come see me today during office hours. The TAs worked overtime over the weekend to grade the quiz, so they're all actually ready to go. But anybody who had like a legitimate reason for missing the quiz on Friday, you had connectivity issues or whatever, please let me know. We'll let you retake the quiz. But once I release the answers, I can't like give you the quiz because you have the answers. So please see me, and we will release the results to everybody here probably about 5 o'clock today. All right, what are we going to talk about today? Today we are on to chapter 6. Chapter 6 was a relatively small chapter. The one topic we are not going to cover today is the text formatting, which, to be fair, I think everyone has seen that already anyways, but we'll cover that on Wednesday. Reminder, on Wednesday, we are doing the quiz on loops. The TAs are taking that this evening. They're going to give me feedback just to make sure that that quiz should be doable. Other than that, today, we are going to talk about the following topics: string slicing, splitting and joining, and some common string methods that were actually introduced back in chapter 3. All right, you should all feel really good and proud of yourselves. You know so much about strings. I think you're going to be surprised when you see the next 2 slides of what you actually know. So fundamentally, we know a string is an immutable sequence of characters. Once we create a string, it cannot change. How do we create strings? We can create strings using the double quotes, the single quotes, or the multi-line quotes. This one right here, particularly, this will come in usefulness. It's going to be useful for assignment 5 when you have to build that pizza menu. Consider using the multi-line string there. If you're getting some issues with that menu, not like putting the right new lines or tabs, try that out. It's not the only solution. Using regular print statements will work, but that might help you out a little bit. We learned about the length function. We know the length function is used for a lot of different data structures, but for strings, we could say len in the string my, that will return 2. We know how to access characters in a string because it's just a sequence. We can use that square bracket notation. We know that the first index starts at 0. We know that the last index starts with the length of the string minus 1. We said that gets a little bit wordy sometimes, so we could use negative indexing. So we can say index -1 is the last character. And the first character is negative length of whatever that string was. We know that there could be errors when we try to access a string. If we have a string that's of length 5 and we try to access something at index 5, we should get index out of bounds because we only have index 0 to 4 in that case. We know how to use certain functions like plus for concatenation. So ABC plus 1, 2, 3, all of these in quotes, yields ABC 1, 2, 3. And you probably see this a lot. I use this to sort of separate out a lot of our code when we do those code walkthroughs. You can do multiply. So if I do the character A times 4, I end up with AAA. So you see a lot of times I'll do something like quote star times 10, something like that, just to give me 10 stars very quickly. All right, so you know all of that. You know so much about strings, but you also know other things. You know about these escape characters. We know that we have /n for a new line, /r, /t, // single quote, /double quote. If we don't want to use those, we can use this instead of F, we can use R. We can use an R string, a raw string, to print out literally /t or /n. Marginally useful. Very importantly, we should really be in the business of using the formatted string, especially when we do print statements these days. So we know how to do things like, sounds kind of funny, F my string or F my variable, right? And put the variable in the curly quotes there. We know how to format the strings. So most commonly, we're dealing with things like floats, where we have that colon comma .03 gives me a string that will have commas in the right place, and it will have 3 decimal places, right? So very, very briefly, if anybody is at all confused with those, Let me switch over to this. In assignment 6.1 string recap. So here is that very, very basic, here's a bunch of strings with the double quote. Here's the one that says single quotes, but it's not single quotes. Put that in single quotes. And here's multi-line quotes, right? So if I go ahead and run that up, you can see I get those three strings. I am a string with double quotes, single quotes, and then we have this funky multi-line string right here. Maybe only that last one should be a little bit foreign. We don't use it too much, at least in this class, but we'll start using it more. This length function, again, there really shouldn't be any magic here, but oops, let me put this in the right spot. If I just say len and I pass my string in it, it's going to say this first string has 30 characters, 39, 43. Indexing a string. Right, the first character of a string, right? I can access that just so if I have this variable simple, I could say simple 0, that accesses character A. If I want to access the last character, I can do the length of simple -1. That will get me this digit 5 here. And then I can also do negative indexing. You can do negative length simple to get the first character and -1 to get the last. Again, hopefully these are not foreign at this point. This is the stuff that needs to be second nature. Okay. Yeah, string operators. See these all over the place. String A plus string B just concatenates the two things. So A, B, C, D, E plus 1, 2, 3, 4, 5 gives me that. And then Y in quotes times 3 gives me Y, Y, Y. And you see the usefulness here where I have this part 4 string operations, right? That's how I do that magic instead of writing 10 stars or having them unbalanced. Right? The escape character, right? If I have a string in double quotes, if I want to put a double quote inside of it, I have to escape it. If I have a string in single quotes, I have to escape it. A /t, that will give me a tab. A /n gets me a new line, right? So we can see all those here, right? You see how I'm getting those printed out. You can see the /t, that's all that space right there. See the new line over here. And then here's that raw string. So instead of saying F string, I say raw, R. When I do / single quote, double, two slashes, /n, /t, it will literally print those out. And hopefully, again, the formatting at this point, hopefully this is all second nature. There's a whole lot of formats out there. Up until now, we focused on the formats for floats. We're going to do quite a few with strings today, right? To be fair, when I give you these on quizzes and tests, I don't think I've asked you to date, like, what is the string for a Boolean? What is the string for this? I sort of ask you to give me an example or to actually utilize that code. For the most part, even today, I'm going to look up in a table a format if I don't know it. If you ask me right now, how do I do scientific notation? I don't know off the top of my head. I'd probably look it up, but I know it exists. Okay, so the first topic that was covered in chapter 6, and again, please make sure you're keeping up with the reading. Chapter 6 is, I'm going to grade that on Friday because we're going to move on to chapter 7 on Friday. So, string slicing. So what is this concept of slicing? Slicing can be applied really to any sequence. So think about a list, think about a set, things like that. Instead of just indexing into a string and getting one character, I want to get more than one. And the way we need to think about that is sort of like carving up a piece of pie. So if we have a pie, we can cut up one little slice. Maybe that's a character. Or we can carve up half of the pie. Or maybe we can carve the pie up into quarters. This is the general concept of slicing. It's getting more than one character using a very simple function. So how would we do slicing today? Today, if I had asked you, hey, get me the first 5 characters, which is the word hello, and get me the last 6 characters, which is the word banana. You should all know how to do this after doing chapter 5. If I said get the first 5 characters, you construct a range that goes from 0 to 5. Why? That's going to get me the characters at index 0, 1, 2, 3, and 4. If I asked you to get me the last 6, hopefully you've become familiar with range in using these negative indexes. Or in this case, I'm saying start at -6 and go up to 0 by 1. So put these two together. If you ran that code, that will get me hello banana when I print that out. But there's a much easier way. We don't do this in programming because, well, we're kind of lazy, right? We want to do stuff that we do over and over again as efficiently as possible. So we have this concept here. So we have that square bracket notation we use for indexing. But we can put some magic inside there instead of just a number. And in fact, I saw some people maybe make a mistake when they were doing some of the earlier exercises. You stumbled upon this lesson. So this code here also gives me hello banana, right? And isn't that a lot more succinct than what we had before? So the syntax for slicing looks like this. Given any sequence, and for the purposes of today's discussion, that's a string or a variable that has a string. You can put an integer which says, I want you to start at this index. You can give it another parameter called end. I want you to end at this index. And you have this step parameter. It's just like what we saw in range. It will, if you put in 2, it will take every other character. If you put in 3, it will take every third character. It's very consistent with range. So the start is inclusive and the end is exclusive. So if you have a string that's length 5, right? If you say 4, it's going to give, if you say 5, it's going to give you the 4 characters that you need. And we'll look at that in the code samples. All right. So again, why is this important? Would you rather have to do all of that or just that to get that, right? But obviously, we want to do this. We want to save all that typing. Okay, let's jump into it. String slicing. Okay, this is what we know today. If I had the string, hello world, I am a banana. I have 2 variables here. I'm going to loop from 0 to 5, and I'm going to store each character, right? I'm saying message, square bracket, index I. I'm going to store that in here. And then I'm going to do the same thing for the last 6. So there's no magic here. Move it on down. Here is that basic example. Hello world, I am a banana. If I want the first 5 characters, I just say, here is my string, or here's my variable that's holding a string more precisely. I said these are optional. So in this case, because I didn't specify a start, it assumes I want 0. And I want you to give me the first 5. Cool. So that gives me hello. The last 6. Here's my variable, index -6, right? So -1 is the last character. I want to go back 6, right? So that starts at B and goes all the way to A. Notice here, I'm saying the start parameter, and I'm excluding the end parameter. I'm basically saying, go to the end of the string, right? So if I change that 6 to say like -10, that will go back to whatever the -10th character was, which is apparently the M in I am a banana. Okay. There are some options here. And again, this is where you as a programmer, you can get creative as you do this. Oops. Copy my variable down here. So here I'm saying start at the 6th character and end at the 12th character, right? So that went, get me the word world. A lot of this you kind of just need to fiddle with. So if you have challenges like this in the quiz, use whatever IDE you happen to be using to make sure you figure that out. All right. This is just another example. 1320. Oops. Row comment here somewhere. So 1320 got me this I am a bit and so forth. All right. This looks a little weird, right? But these things here are all basically the same. So if I say message, nothing in start, nothing in end, and nothing in step, it prints out the whole string. If I put a 0 in here, this is going to start at 0, and it's going to go all the way to the end, and it's going to step by 1. Very convenient here is if I want to print my string backward, if I want to reverse my string. I think we had this challenge somewhere else before where we had to iterate backwards, right? Here I could just say, I want you to go from the end to the start by -1. And that gives me this whole string backwards. Yeah, and then this is just that last property again that we've come to know and love from looking at ranges, the stride parameter. So here if I say : 2, that gets me every other character, which is that. And here's every 3rd character, but just going up to the 7th character. All right. Okay, so play with those. I think the best way to learn those, there's a bunch of exercises in Zybooks, or just open up your favorite IDE, use EdStem, whatever, and just start mucking around with those. Okay. The next section in chapter 6 was on splitting and joining. So what is splitting? Well, this is a great example. This comes up all the time in programming. A lot of times when one system is talking to another system, they're fundamentally sending strings back and forth. In a lot of cases, those strings, they're structured. They're in something called XML a lot of times, or they're in JSON. But whatever it's in, a very common problem is, here's a list of sugar, rice, apples, and I'm using a delimiter or a separator, a hash sign, right? And if I wanted to sort those alphabetically, there's a lot of gobbledygook here, but we know how to do that today. We would just basically create a loop that would iterate over each character in this string. And every time we saw that hash sign, we'd say, ooh, okay, I've gotten a complete word. Let me store that in a list or do something with it. Sort that list and then do the inverse, print it all back. Because all of that is so complex, because this happens all the time, there is a method on string called split. So if I have a string, in this case, the string is the variable unsorted ingredients. If I say split on the hash symbol, I end up with a list. The list that we all know and love today. Hopefully we've had some experience. I saw some people using some functions. You can use the IDE to code complete and get some of this. We have a sort function on that list, which is going to sort everything alphabetically. So breaking this down a little bit, these things are called tokens. The thing here, this hash symbol, is a separator. It doesn't have to be a hash symbol. It might be a dollar sign. It might be a space. It might be a tab, right? Things like that. Okay. The opposite of splitting is joining. So let's say I have a list, right? And how did I get a list? Well, I just took this string and I split it. So I ended up with that list. Another function on string is called join. So I can say # join that list. That will give me this string back over here. All right. I'm going to leave this stuff for you to view in the slides if you want. This really breaks it down. I tried to color code things a little bit here. But I think the best way to learn this stuff is just by coding, by practicing it a little bit. But you can kind of decipher all of this. The key thing to remember, split and join are the inverse of each other. Split splits a string and gives you a list. Join takes a list and gives you a string. All right, let's get into it. All right, splitting, what we know today. If I had this thing, what would I do? So what I would do today, if I didn't know about split and join, I would say for C, for character in my shopping list, right? If C equals, let's say my delimiter here is a #, then I know I have a completed word. So I'm going to keep a variable here called word. I'm going to create another variable called my list. So if I see a delimiter here, I'm going to add C to my current word, and I'm going to add it to my list. My list.append word. If I don't have a #, I'm just going to add the character to my word. Okay. Because we should be taking baby steps, I'm just going to print that out. Let's see what that gives us. Whoops, what did I do wrong there? Append. Okay. Close. What did I do wrong? Oh, I forgot to clear out this word. So let's clear that out. Word equals back to an empty string. Now I have sugar and rice. Gee, where did that, what else did I do wrong here? Oh, I have that # symbol. So if it's # symbol, I don't want to do this. Let's get rid of that. You see something really useful here. Hopefully you got into chapter 5 in loops, that concept of the for else. Here's a good place for that for else. Here, I have a completed word somewhere there. I can take my list.append word. Watch what happens there. Now I get sugar, rice, apples. Pretty cool. All right. Cool. So that's kind of what we would do today. And I'm going to save this just so we can move on. Hopefully you all see I can iterate over that list now and print the words out in reverse order, something like that. But I want to move on and show you how we do this in split. Because what I just showed you there, you should know how to do from what we learned in the loops chapter. Okay, so let's just see how easy this is. I want to split up my shopping list, right? My underscore list equals my shopping list dot split. Oops, hash symbol. Let's print this thing out. Print my list. I got the same thing. There's a lot less code, right? All right. Let's move it on down. How do I do that joining now? This might feel a little uncomfortable, but it's the way we have to do it. If I wanted to now like switch that delimiter, I wanted to make it a $sign. I say $sign dot join. I'm gonna take my list. I gotta catch this somewhere here. Call this new list. Print new list. There's my new list. Oops, I forgot that one thing I wanted to do. I wanted to sort this. Just do my list dot sort. Apples, rice, sugar. Pretty straightforward. Right. I will leave these for you to do as exercises. As I mentioned here with these coding challenge samples here, I'm giving you the solution. You have the solutions right here. I encourage you to try these on your own first. But if you do get hung up, right after class today, I'll make sure these are unhidden, and you can look at all the solutions for these. Okay. The next section covered in chapter 6 was common string methods. And again, these were introduced in chapter 3. If you wanted to look deeper into them, you could have. But now you're going to have to look into them. So very common with strings, we have to do find and we have to do replace. So this is a very common problem here. This is a little contrived, but count the number of F's in the following sentence. And it's hard to eyeball it. I dare you to figure out what they are, but I counted these up before. There's 6. But if I'm not sure, guess what? There are a bunch of functions. Find with 2 parameters, find with 3 parameters. This pattern should get familiar now. Doesn't this look suspiciously like the syntax for range or the syntax for slicing, in that I have a string that I'm looking for, I have a start and I have an end, right? With find, there would be no concept of a step, but there's always sort of this, I want you to start looking at this point in the code or this point in the string for something, for X. Please understand the way these work. These are methods on a string, right? So all of these examples here, like the little examples you have on the slide here, when I have a string S that has the value hello world, I'm doing S dot find the word hello. I'm doing S dot find the word hello starting at index 10 and so forth, right? rfind just searches in reverse, finds the last, and count is sort of lumped in here. Just count the number of times X ends up in that string. The other side of find is replace. Most of the time, you're not just looking for a character, you're looking to clean up some stuff. This happens all the time. Like you have a program, you have code, somebody misspelled a word 8,000 times, right? Maybe you've done this yourself. You've written a document in like Word or Google Docs or something. You're like, oh crap, I misspelled XYZ everywhere, right? You do find and you do replace. This is what's happening, right? So I have these 2 functions, replace And again, just like with find, you use the string, in this case, the string, which is the variable s, and I say I want to replace the word hello with howdy. Right? You can look back in your notes on chapter 3. Again, we did this in chapter 3. We looked at like replacing something with the word sun in it, I think. Okay, let's take a peek. So, counting. And this is, I'm going to do this just for the sake of folks that are still catching up on loops. If you're just in chapter 5 right now, you're not paying attention today, how would I find all the F's in a string? You would do this. For character in my string, and let's keep a count variable. Count 0 if C equals the character capital F, C++. There are count F's. Since I'm using my format string there, I'll put my F in there. Oops. C plus equals 1. What I just did there is what you would do in well, most every other program language. Why don't you like my comment? Anybody see what I'm doing wrong there? Unescape code, line 14. Oh, silly me. I tried to increment a character, not my count variable. Oops. Doesn't like some character I have in here, but let's try that out. Yep, okay, there's 6 F's. So that's what we know how to do today. How are we going to count them going forward? Well, we're just going to say print my string dot count. And what am I counting? The F's. F's are in my string. All right, I really do not know why it doesn't like that. All right, there are 6 F's in my string. Let's try replace. This is something that comes up all the time. We have different operating systems. Most notably, you'll have Windows, you'll have Mac, you'll have Linux. A Mac operating system is very close to Linux. The way files are stored on different file systems are different. So if you're on a Windows PC, it would look like this: C:/, usually your drive or your partition, and then these are the folders until eventually you get to your file. If you're dealing in Linux, they don't call them drives, they call them mounts. And so we need to make that change, and we need to change slashes that go this way to slashes that go that way, right? So if I wanted to create a Linux path here, oh, and notice here, this was one place I found a use for this raw string, because otherwise this would have been you would have thought all these were escape characters, which they're not valid escape characters, so it would get really mucked up. So here, if I want to replace all of those slashes, I can do this. Replace forward slash with a backward slash. Let's see what that gives me. Maybe we'll print out the Windows path just so we can see the difference side by side. Okay. So, yep. So I achieved replacing all those. And then now let's do that last bit. And I don't just have to replace characters, I can replace whole strings, right? So I'm going to say my Linux path is my Linux path dot replace. And I'm going to replace the mount here for the drive in Windows. And that's going to be a raw string, so I get that slash. And replace that with, what did I say? Slash mount C. Oops. Somebody's not happy there. Oh. See. I'm doing something wrong there. Not entirely sure what. Oh, duh. I've already replaced my slashes. I just wanted to replace that mount part. There we go. So I replaced, yeah, just that C. What's nice about these is we can chain them together. If we want to be a little more succinct, I can say replace this and then replace that on that, and I'll get the same thing. All right. The next one, I decided to actually put these into the quiz. So just to make quiz 6 a little bit easier, I'll leave these as a challenge for you to do here. So to get some practice, here's a string. The cat sat on a mat and chased a mouse. Produce a string. The fat cat on the mat ate a mouse. So in this, you'll be looking to replace the first instance of C with F, the first instance of S with C, replace all commas with an empty space, and replace this whole string, then chased, with the word ate. So give these a shot. There'll be something very similar on quiz 6. So just so you're not like futzing around with an IDE during the quiz, take a look at part 4 and part 5 here. Because you'll see them again in the quiz. Okay. Next thing, inspecting. So a lot of times we want to know what is a string. And these are very common methods. And again, just like with those other 2 sections we looked at, These are methods, these are functions that you call on a string itself. So if I have the string hello world, this function is ALNum, is digit, is lower. This one's kind of interesting. I haven't seen that in many other languages. It returns true if the characters are lowercase, uppercase, or numbers. Basically, it's anything but a symbol, really. Is digit is pretty straightforward. That comes in handy. You see that in a lot of languages because, you know, a user's at a keyboard and they're entering in information. Sometimes you want to know, like, hey, I asked them to enter in their age. So is what they gave me an actual number, right? Because we all know, we've experienced this several times. When you do like int input and you accidentally put in the letter A, right? The code blows up. It's like, I can't convert A to an integer. If you capture it as a string, you can ask it, whatever string the user gave, you can say is digit. So if they gave you a digit, then you can safely pass it to an int. Is lower, is upper, is space. Pay attention to this. This is a little bit of a gotcha. I don't really like that this is in Python, but tabs and newlines, they consider those spaces. So not just a literal space character. So pay attention to that. I feel like that's more confusing than if they just kept them out. Another little weird thing with is lower and is upper, and we'll look at this in a minute, but certain punctuation doesn't have a case, but if you have a string that says like hello with an exclamation mark, it'll say, yeah, that's lowercase because it ignores the punctuation. Starts with and ends with, very useful. Does the string start with this string? Does it end with this string? All right. So, inspecting. Here's a great big old string, but it's just a bunch of capital letters, lowercase letters, and numbers. If I run that up, is all num returns true. The rest of these, hopefully they won't come as a big shock. Digits. If I have the string 1, 2, 3, are these all digits? It's true. Yes, it is. Remember, don't conflate digit with number, right? Because like 1, 2, 3.1, it's a valid floating point number, but it's not all digits. So that's going to return false. All lowercase and all uppercase. So all lowercase is all in lowercase. That returns true, even though I have an exclamation mark. And watch what happens if I just made that an exclamation mark. It returns false, right? So it's a little confusing. You kind of have to get used to it in Python, but the way it is. It's the same thing with upper. So here's uppercase, even though there's an exclamation mark. Oops. I'm going to say that should this way. Returns true. But if I just have the exclamation mark, returns false. So pay attention to that. Here's the little craziness with the spaces. So here's my string, a /n, a /t, and a space. That returns true, right? And it's not just because of that space. Just got rid of that, it's still true. If I got rid of the tab, it's still true. All right. And finally, starts and ends with. Very useful functions. If I have this message, hello world, and I say, does this start with H? Notice how it's case sensitive. So small h returns false, but capital H returns true. I'm not limited to just dealing with characters. I can ask for whole strings, right? I can say, does this thing start with hello? Oops, send me a variable here. So it starts with that whole word. Okay. To close it out, modifying is the next set of methods that we've seen in chapter 6. Lower, upper, strip, capitalize, and title. Hopefully you had some practice with lower and upper. I think we looked at those in the debugging part of the assignment. I forget which one. Assignment 4, something like that. So modifying, pretty straightforward. This strip one is very, very useful. So I was given this string with some blank space at the front and the back. And you can see here when I say strip, it strips those out. It gives me a nice clean string. Lower and upper. Again, these are very useful. If I have a string here in uppercase, this is all uppercase, and I say lowercase it, makes it in lowercase. Lower does the opposite. That's very useful for menus when you're asking a user, enter in Y or N. You don't know if the user has cap locks on, so normally you accept both. A little peculiar and unique to Python, these last two, capitalize and title. And this is just something you have to remember. Title basically turns a string into what you would see in the title of a book. Every first word is capitalized versus capitalized, which just changes the uppercase of the first letter. So I'll play with those. Okay, coming up, homework 5, that will be graded tonight. So please make sure you complete homework 5. Wednesday, we will do the quiz on chapter 5. Remember, that's the chapters on loops. So make sure you get done with loops. Thursday night, the assignment 5 for loops is due. You may have some time in the lab. I wouldn't bank on it because we have a busy lab this week, but you have time there. Homework 6, we will have a little bit more on Wednesday after the quiz. That homework will be due on Friday. As I mentioned, the course starts going really fast now because we've got to get into the project. All right. Make sure you read chapter 6.2, advanced string formatting, and get on to chapter 7. We will start that on Friday. Assignment 6 is open for business too, for those who want to get a head start. Very nice.
So I have the AIO running through. No, absolutely. I mean, so my last week that I had and I took out had a rise in five that I just took it out. This is just supposed to last.
That looks really nice.
And I actually cable managed it well.